Volumes using cross sections. Okay, the base of the saw is a triangular region in the first quadrant, and is bound by this graph and the x and y axis. So let's draw a picture really quick. I got my function right there. You see, got my y-intercept at 4. The slope is -2 over 1 because that's the number that's multiplying to x. So I go down 2, right 1. And it looks like we got our triangle. Okay, we're bound by the x and y axis. And then we get to the part where it talks about the cross sections. The cross sections in this one are perpendicular to the x-axis, which we all know and love because we'd rather integrate with respect to the x-axis. Anyways, so here we go. Let's find our area function. We know that our cross sections are whatchamacallit, they're squares, right? Where does it say that? For the solid, each cross section perpendicular is a square. Okay, so we know that squares are found. The areas of squares are found by squaring one of the sides. These lines right here represent 2 of the cross sections. Now we know that there's infinite inside here. I just drew 2. But these represent one side of our square. Now the problem with this is that the area is not written in terms of x yet. We have to define s, which is a side, in terms of x. Now these lines right here, their length is determined by the y value at the point at the end. And that y value is found by taking 4 and subtracting 2 x's. All right, so there's our side. So instead of writing s squared, we're going to write 4 minus 2x squared. Now we have an area function for our cross sections. Next thing we do is we integrate that area function. To simplify this one, I'm going to have to do that power, which is 4 minus 2x times 4 minus 2x. When I do that, I get 16 minus 16x plus 4x squared, and I have to integrate that. Now, in order to integrate that, I need my lower and upper bound. Actually, I can do an indefinite integral, but that's not going to give us an answer. We need a lower and upper bound here, okay? So we need the smallest x and the biggest x that we get from our region. The smallest x is right here. It's 0. The second one, we don't know. Now, there's 2 ways to figure this out. You can just do the slope and figure it out that way, or you can set the equation equal to 0. And when you do that and solve it, you get x equals 2. And so that's our upper bound. Now I must do the antiderivative. When I do the antiderivative of 16, I just add the x. When I do the antiderivative of 16x, I add 1 to the exponent. So I get x to the second power. And then I divide by that 2. Divide 16 by that 2, which is why you see 8 right here. For this one right here, we add 1 to the 2, we get 3. Then you have to divide the floor by 3. And your antiderivative is finished. Now I need to plug in the 2 and then plug in the 0. Subtract the 2. It's always top minus bottom, by the way. So when I plug in the 2, I get 32 minus 4, 8 times 4. Plus 4 over 3 times 8 minus 0. I love it when they have a 0 here and everything's multiplied by x. These guys cancel out because they're both 32. And then 4 times 8 will give me 32 over 3. And that is my answer.